All right. How we doing, ladies and gentlemen? Hope you're all healthy, living the dream. I mean, this is what you guys always wanted, right? Is to sit at home and not do work. Actually, you do probably heck of work. I don't know. You guys probably sit around and goof off all day. Anyway, welcome back. I know you've all been waiting with much anticipation and bated breath for this next video. Don't mind that sound over there. That's my dog walking on my tile. We're going to talk about complex factoring today. So far we've done simple factoring. We've dabbled a little bit with GCFs. And we have done factoring by grouping. That's when there's 4 terms. So the last kind of difficult kind of factoring we're going to learn today, this is probably the hardest one, which is why I made your homework a few less problems this week. We're going to do complex factoring. So this is just fancy. That's what quadratic looks like. So the first question you're going to ask yourselves, if you ask yourself questions, is how do you know to do complex factoring? That's an excellent question, my dear child. There are 2 things you want to look for, 2 of them. They have to have 3 terms in the polynomial. So this would be 1, 2, 3. If we look down here at a couple examples, 1, 2, 3, 1, 2, 3. So these both have 3 terms. We're good to go. So that's not going to help us. The other thing we have to look for is we're looking for an A that does not equal, that's what the little line through the equals means, 1. So if we go back up to this title, A is the number in front of the x squared. So we're looking for, is the number in front of the x squared not 1? So if we look down here, this x squared doesn't have a number in front of it. So what that means is that there is an invisible coefficient, and that invisible coefficient is 1. Because this is a 1, we're looking for A not 1. So this is not complex factoring. This is actually simple factoring. This is the easy peasy stuff. And hopefully you all know that you can factor this to x plus dos e x plus 1. So that's how that factors. That's just simple factoring. If we look at the second one here, we still have our 3 terms, 1 term, 2 terms, 3 terms. And if we look at the number in front of the x squared, this number 3 does not equal 1. So because there's a number here besides 1, because it's not blank, this is complex factoring. So really what you're looking for are there 3 terms, and is there a number in front of the x squared that's not 1? If those 2 things happen, we're going to do some complex factoring. So I'm going to hit you guys with 2 examples. Actually, I'm not going to hit you because that's illegal. Actually, fun fact, in the state of Arizona, teachers are legally allowed to hit kids. It's just really frowned upon. I definitely lose my job, but I probably wouldn't go to prison. So I'm going to provide to you and demonstrate to you 2 examples of complex factoring. All right. Words are tough. Talking's hard. Except we do it live. We don't do second takes here. The first example we're going to do is the one we just saw. So we've already said this is going to be complex factoring because we have 1, dos, trace, get it? Ha ha ha. Like, see there's a square. And then I'm going to trace it. Trace. Anyway, we're going to factor this. So there are a couple of steps that we need to do for complex factoring because there are 3 terms and a number in front. The first thing we're going to do is we are going to take our A value. No, we're not. Step 0. I always forget step 0 because I count from 1. I'm more of a whole numbers kind of, or not whole numbers, natural numbers kind of guy, not a whole numbers kind of guy. But anyway, step 0. Step 0 is take out the GCF. Okay, there isn't a GCF here, which is why I almost forgot to do step 0. 3, 7, 2. There are no common factors for 3, 7, and 2. The only numbers that go into 3 are 1 and 3. The only numbers that go into 7 are 1 and 7. 1 doesn't count because 1 goes into everything. So 3 and 7, nothing in common. So we can't take out a GCF. They also don't have any variables in common. We have x's, 1x, no x's. Because they don't all have an x, we can't take out any variables. So step 1, or step 0 rather, is take out a GCF if possible. But it's not always possible, like on this one. So actual step 1, if we're going to do complex factoring. We see the 3, we go, complex factoring. Step 1 is multiply a to c in ax squared plus bx plus c. So what that means is we're going to take this first number, we're going to move it to the rear, and we're going to multiply it to that back number. So after we do this first step, we're going to have, let me get my colors straight, x squared plus 7x plus 3 times 2 is 6. All right, so we did step 1. We took the first number, we multiplied it to the last number. Now, step 2 is we're going to take this new thing and we're going to do simple factoring. Simple factor, factor, the result of step 1. Okay, so we're going to look at this thing. We're going to do simple factoring. So we need two numbers that are going to multiply to 6, and they have to add up to 7. So we'll look at our factors of 6. I like to do it with a little t-chart. So we have 1 times 6 and 2 times 3. So I need to use one of these pairs of factors, either the 1 and the 6 or the 2 and the 3, to make a 7 by adding and subtracting, or subtracting, not and. So 2 and 3, if I add those, 2 plus 3 is 5. That's not big enough, and that's as big as it's going to get, so you can't make 7. So 1 plus 6, though, that's 7. So we're going to use the 1 and the 6. So this factors 2, x plus 1, because we're using a positive 1, and x plus 6, because we're using a positive 6. And we can just double check real quick that everything works out. We can ask ourselves, is 1 times 6 6? It is, so that's good. And then 1 plus 6 is 7, so we're all good there. It adds to the middle number and it multiplies to the last number. Those are some beautiful check marks. Someday I hope you too can learn to write check marks so immaculately. All right, step 3. You're going to say, Barton, look, it's factored. Joke's on you. It's not factored. There's more steps. Not joke 3. Step 3 is divide the numbers in, I'm going to put pounds or hashtags because I can't spell the word numbers. Divide the numbers in the result by the original A. Okay, there's a little bit more that goes into this, but I'm not smart enough to write it out. That's why I'm going to make an entire YouTube video on what to do. So our original A value, we look way back up here at the original problem, is 3. So now what we're going to do is we're going to take this 3 and we're going to divide these two numbers by that original A. So we put it over 3 over 3. All right, let's do the easy one first. 6 divided by 3 is 2. So this thing is going to turn into x plus 2. Okay, that one's done. That's part of our answer. This one, though, 3 doesn't go into 1. So this is what you're supposed to do. You take your denominator. Can we reduce that first? No, we can't. 1 and 3 are both prime numbers, so it's not going to reduce. You should reduce first. Let's even write a little note here. Reduce first if possible. There you go. It's Italian, see? Possible. But we can't reduce this. So what we do instead is we take this 3 and we actually move it in front of the x to get 3x, and then we just bring down this piece here, plus 1. Okay, this is our answer. This is completely factored now, and those are the two things that we can multiply together to make this. You could FOIL this out. Here, I'll even do it for you because, you know, I don't have anywhere to be. I'm stuck indoors. So let's FOIL this just to check our answer and make sure it's correct. This is the answer though, and I know that because I made up the problem. So we're gonna FOIL this together. 3x times x. Ooh, see that shaky hand? I've been indoors too long. That's 3x squared. 3x times 2, if we're doing our distributing. 3 times 2 is 6. Bring down our x. Now we go to the next term. 1 times x is x, and 1 times 2 is 2. Now we combine our like terms here. 3x squared doesn't have any other x squares to combine with, so we're just going to drop it like it's hot. 3x squared. 6x plus x, this is 1x. Because they're both x's and we're adding, we can combine these like terms. So 6x's plus 1 more x, that'll be 7x. Now this 2 doesn't have any x's. There are no other numbers without variables on them, so this doesn't have any like terms. So we just drop that also. And now we can see this matches our original problem up there. So because those are the same, we know that we have factored correctly and we are good to go. So that's an example of complex factoring. I'm going to do one more with you guys to show you the importance of step 0 and just to give you a second example of these 3 steps so that, you know, if that one wasn't clear enough, maybe you got something else to try and pick up on. As always, excuse me, sorry, I'll be more professional next time, I swear. If this is confusing or you need help, email me, send me a message on Band. Send me pictures of the problem you need help with, things like that, and I can try and help you. Or we can schedule a WebEx if that's really what you're into. But, all right, you could even rewatch the video. That's why I post them. All right, example numero dos. I'm not going to rewrite these 4 steps, so you're going to have to either memorize these, which is, you know, what every good student would do. Or you can just go ahead and like take a screenshot of them, forget them entirely, say, wow, Barton, that's stupid. I don't ever want to do that. You know, the usual stuff. So there are the steps. Make sure you either have a photographic memory or you wrote them down so you can peek at them while we're doing example 2. All right, example 2. So step 0 is the most importante one on that list. Example 0 is take out the GCF if possible. So if we look at this, 4, 10, and 6, those are all suspiciously even numbers, which means they do have a GCF. Our GCF here is going to be 2. So we need to take the 2 that goes into 4, 10, and 6, and we need to remove it from the problem by factoring out the GCF. Otherwise, our answer is not going to come out correctly using this complex factoring method. This is also usually called either the box method or the monkey method if you want to try and Google it by someone who teaches better than I do. So step 1, take out our GCF, and here we go. So 2 is the GCF. That's going to go out in front. This is like your little brother, okay? He's not important. He's really, really annoying. He just gets in your way, asks you to buy him stuff all the time, tells your mom when you do drugs, stuff like that. So we don't really care about this too, but it's like taking your little brother to the mall. You don't have to be nice to him or buy him anything or, you know, really even acknowledge his existence. But if you lose him, your mother is going to be ticked, and then you're going to be homeless too, just like him after that. So we don't have to do anything with this GCF. We just can't lose it. It has to come home with us. So don't lose your little brother. Okay. Now we ask ourselves, how many times does 2 go into each of these? So we're dividing by 2. Okay. So 4 divided by 2 is 2. Bring down our x squared. We're not taking out a GCF with any variables in it. 2 goes into 10 5 times, so plus 5, bring down our x, and then 2 goes into 6 3 times. Okay, now what we want is we want to factor that chunk right there. This 2 doesn't do anything for the rest of the problem. It just kind of follows along, and our final answer, wherever that goes, we'll just put it way down here so I have enough room. We're going to have a 2 in the very front of it. That's that GCF that we took out to start with. It has to be on the front of your answer, otherwise it's wrong. but it doesn't do anything. You just take it out and leave it in front for the rest of your life. Okay. Now, this chunk underlined in red, we are going to repeat these 3 steps now to do the complex factoring on that. So I'm going to just bring down this 2 so I don't forget it. Remember, don't lose your little brother. Now we're going to do the complex factoring here. So we're going to take our leading coefficient and we're going to multiply it to the last number and rewrite that. I'm going to leave this in parentheses because I'm only working on this. This is the only thing that's going to change. That 2 just needs to be separated, so we use parentheses to separate things. So x squared plus 5x plus 6. Okay, so we multiplied the first term to the last term. Now we need to do simple factoring on this. So we need 2 numbers that multiply to 6 and add up to 5. So we go look at our factors of 6. There's 1 and 6. I could do 6 minus 1 to get 5, but if I do 6 times -1, I get -6. And this is a positive 6, so these aren't going to work because the multiplication doesn't work out correctly. So our other factors of 6 are 2 and 3. I can add 2 and 3 to get 5, and I can multiply 2 and 3 to get 6. So we're going to use the 2 and the 3. So again, the 2 doesn't do anything. This is just our GCF. It's our little brother. We can't lose it, but it doesn't do anything. So we just let it follow us around. 2. Now we factor this with the 2 and the 3. So this is going to be x plus 2 because the 2 is positive. And then this could be x plus 3 because the 3 is positive. So this has the simple factoring done. Now, the most important part, this is the step that everyone in high school always forgets because remembering 3 steps is too difficult. Now we need to divide the numbers in these binomials by our original A term. And our original A term doesn't mean the 4, it means the A term that we multiplied to the last number. So when we did the multiplying, we did 2 times 3. So we're going to divide by 2, not by 4. Okay, so let's bring our 2 down. Divide by 2, divide by 2. This one's easy. 2 goes into 2 one time. So bring down our leading coefficient. Oh, look, it's already there. It's like I knew it was still going to be there. That's crazy. Bring down your x. 2 divided by 2 is 1. So plus 1. There we go. Now, for this chunk, 2 doesn't go into 3. Does it reduce, though? Reduce? Okay. No, it doesn't. It don't reduce. It don't do that. So, because this doesn't reduce, all we do is we take the denominator and we move it in front of the x. So we have 2x plus 3, and then this is our answer. And if you don't believe me, you can point PhotoMath at your screen right now, tell it to multiply those together however it is you talk to PhotoMath, and it will tell you that I am correct. And I know I'm correct because I'm a freaking genius. Also, I'm a hard worker. If you guys need help, let me know. You guys have your questions posted on Student View, so good luck with those. There's less questions than there were last week because the questions are a few more steps and a little bit harder. And, you know, I didn't want to scare you too much when you're home alone. You know, it's different when you're at school, when you're in a nice sheltered environment, and I can make sure there's no wild math problems attacking you. But, you know, maybe your parents walk into your bedroom and just throw math problems at you. So we'll take it easy this week. So if you guys need help, let me know. Don't leave a comment below because you're going to write something inappropriate. So I've just disabled comments. I don't need any of that negativity in my life. Hit me up on Band, email me. Stay safe, stay healthy, wash your hands. Love you guys.